Well, Pete, let's start with Mercury, the innermost planet. This is easily done because it's down low in the west of the sky, poor altitude after sunset. We're not likely to see it, are we?
No, not really. It's not the best month for Mercury. We've had some good appearances of it this year, so that's not too bad. We can put up with that. Venus, of course, completely different story, but I'm afraid you'll have to get up early to see Venus because it's now in the morning sky. It's very well positioned all month long, rising about 4 hours before the sun. But it is starting to get quite small now.
It is. So it presents a 19 arc second disk, 59% lit at the start of the month, but by the end of the month, it will have dipped a little bit, been minus 4.0 magnitude, but 15 arc seconds across. That is notably smaller, so it'll be a bit tougher to see towards the end of the month. Personally, I tend not to get up and see it in a dark sky. I tend to observe it during the daytime, and that's easily done if you know how to find Venus during the day with setting circles. You have to be very careful, of course. But one thing you do have to remember is that if you're following Venus, if your drive fails, it can drift towards the sun when it's in the morning sky. So there's a lot of extra cautions you have to take.
Yeah, there are, and it's actually at a reasonably safe position at the moment because it's moved quite a way away from the sun. But yeah, that's good advice. I can remember after it passed through inferior conjunction in June, because I'd followed it all the way through May because we had that fantastic run of clear weather right up to the day before inferior conjunction, and then there was a clear patch just after inferior conjunction, and I thought, should I have a look for it? Now, I don't like doing that because there is that danger that if your drive fails on your telescope, the telescope stops tracking and the sun drifts into the field of view and you're in trouble. And in the end, I decided not to do it. There was a few clouds and things started to appear, and I thought, no, it's not worth the bother. And I'm quite glad I didn't because I actually had a power cut here. And I drive from a mains transformer, so that would have happened.
Yeah, it could be very, very dangerous. So you bet you're counting your lucky stars that you didn't do it, Pete.
Slightly, yes. I've got a camera left, which I wouldn't have had otherwise. Okay, well, let's have a look at what is rapidly becoming the best planet on view, which is the planet Mars, which is now heading towards opposition. It actually reaches opposition on the 13th of October. But at the moment, it's pretty amazing, really, to see in the sky.
It is. It dominates the night sky. I think it's because we're not used to a lot of colour in the night sky. And something like Mars, which is almost, I would describe as shockingly red. It's so overwhelmingly colourful that you notice it as soon as you see it, especially because it's so bright. So it is even if just looking at it with the naked eye, it's a very remarkable object in the night sky. On the 10th of September, the planet's apparent eastward motion, I should say, against the background stops. So Mars then reaches what is known as its stationary point.
Yeah. So after the 10th of September, it appears to be moving to the west. Of course, in reality, it hasn't changed direction at all. It's just the consequence of our own orbital motion compared to that of Mars. But it's actually getting larger through the eyepiece as well. So on the 1st of September, a telescope will show it to have a disk which is 18 arc seconds across. And by the time the end of the month has arrived, it'll be absolute Mars luxury because it'll be about 22 arc seconds across. Can you imagine that, Paul? 22 arc seconds.
It's an enormous size. And a 3-inch refractor or 3-inch refractor or telescope that size will show quite a bit of detail in good conditions. So this is a time when anybody with whatever size telescope you have, now's the time to get out and have a look because there'll be some stunning details available. People with larger telescopes really in for a treat. You're going to catch all sorts of fascinating, intricate details in the albedo features, in the ice cap, and various other locations. You also get mists and fogs collecting in the basins and valleys It's such a dynamic planet, and as you say, Pete, 22 arc seconds, an enormous size to have.
Well, it's also quite good for imaging as well, of course, because it's bright. So there's a big signal there to latch onto. At the beginning of the month, it'll be magnitude minus 1.8, but by the end of September, it will have increased in brightness to magnitude minus 2.5.
That's
Actually,
really bright.
Mid-month. Yeah, mid-month it actually overtakes Jupiter in brightness, so that's how bright it is. And I'll tell you what, there's an interesting point you mentioned earlier on. You said it'll look, we don't get much colour in the night sky, and it will look stunningly red. But that's an astronomer's red, isn't it?
Yes.
When you talk about red stars, they tend to be orange in colour, an orange hue. And the same with Mars. Mars sort of has that salmon pink appearance to it.
It's a salmon pink colour rather than a deep dark red. Yes, it's a salmon pink. But at magnitude minus 2.5, it will be shockingly obvious in the sky.
Yeah, I agree completely. And the ice cap you mentioned, it'll be the southern ice cap, the southern polar cap, which is pointing to, well, not pointing towards us, but tilted towards us, which we'll be seeing.
Yeah, that's right. So earlier in the year, it was sort of springtime on the southern hemisphere of Mars, and the cap was quite large. Now it's shrunk right down and is quite small. And what tends to happen is that all those volatiles that are released when the cap's evaporated, all of that goes into the air, into the thin Martian atmosphere, and this is what allows the fogs to form and collect in the basins. So if you look at, particularly on the terminator, so either the east limb or the following limb or the preceding limb of Mars, it's not uncommon to see these brilliant white clouds collecting over the mountain ranges, and you can watch them. They're not static; they change and evolve over time. The ones on the morning terminator tend to dissolve away as the sun rises and heats up the valleys that they're in. So it's really quite a dynamic world you can watch from your own back garden. I never tire of it.
It's going to be amazing. I'm really looking forward to that. On the evening of the 5th of September, Mars is joined by an 87% lit waning gibbous moon. And at 2300 BST on the 5th, both objects appear 3.2 degrees apart, measured from the centre of the moon's disk. Over the remainder of that night and into the morning of the 6th of September, the separation continues to reduce, reaching a minimum value of around half a degree around 0630 BST under daylight conditions. And with Mars being so bright at that time, it should be easy to follow the pair with binoculars or a telescope despite the sun being up. And that's quite close, actually, half a degree from the centre of the moon.
It is. Hopefully, if it's clear here, I shall give that a go. And it would be interesting to see just how easy Mars is to see in a telescope during the daytime, particularly in a finder's scope, but you just see against the background sky.
Well, presumably it should be fairly good in terms of the contrast because it's a reddish coloured planet and the sky is blue.
Yeah, so I think that and the brightness means it should be fairly easy to pick out.
Yeah, okay. Well, that'll extend your Mars observing period then into the day. So the two gas giants, Jupiter and Saturn, they remain very low down as seen from the UK, but they are quite close together in the sky, being about 7.4 degrees apart on the 30th of September. And I think that'll be the highlight for Jupiter and Saturn over the coming months, the fact that they are a pair in the sky.
Yes, a pair very low down, just scraping the tops of the trees. But nonetheless, as I always say, it's still worth having a look at these planets because they are beautiful, wonderful gas giants. And, you do get, in the early hours of the morning, 12:01 in the morning, you can get periods of stable seeing, even when the planets are very low down. So you can then try and make the most of it. Doesn't last very long, I find, normally about half an hour, but long enough to try and catch, either image something or get a drawing.
Yeah, okay. Okay, well, heading out even further to the ice giants, let's go with Uranus first of all. And Uranus is actually quite well positioned during September, located in the southern part of Aries. And actually that places it quite close to Mars. But of course, whereas Mars is in negative magnitudes, Uranus is shining away at plus 5.7, which, although it makes it theoretically visible to the naked eye, is a tricky thing to pick out with just your eyes.
It is. I've only ever done it using the finder scope and setting circles. You can star hop to it if there's some bright stars nearby. You can use that method, but I tend to use setting circles, and that a low power eyepiece, you can normally pick out Uranus quite quickly because even at low power, there's got this distinctive greenish hue, which is quite unmistakable.
It's going to be a bit trickier this year, actually, because it's in a part of Aries. I mean, Aries is not the best constellation to navigate through. That there are the three stars which form the main shape in Aries, if you like, but the rest of it's pretty faint and obscure. So you haven't got much as a navigational guide. So you're heading to the southern part of Aries, between Pisces and Aries, to the north of Cetus. And if you can navigate that without a little bit of assistance, good on you.
Yeah, it is difficult, isn't it? But nonetheless, worth a try. As I say, I think most telescopes now, certainly all the telescopes on equatorial mounts, can be setting circles. Might be a good idea to give those a try to tighten up those setting circle skills.
Yeah, that's a good idea. And Neptune, of course, is, well, the key to finding Neptune is to look for Phi Aquarii, because Neptune will be near Phi Aquarii for some time now. So Neptune reaches opposition this month on the 11th of September, but unlike Mars, opposition doesn't make a huge difference to the appearance of Neptune. It'll be shining away at magnitude plus 7.8, so you'll need binoculars to see it. And at the moment, it's about 2.1 degrees east-northeast of mag plus 4.2 phi. So phi is definitely the key to locating Neptune in the sky.
Yeah.
Okay, well, let's move on to some of the specials which are occurring in September. And the first one picked out is actually a bit of a payback, because we hear all this stuff about supermoons in the sky, which is...
Dear.
Oh, there he goes, he's moaning already. A supermoon is basically a term introduced by an astrologer, and it's one of those annoying terms which has caught a bit of traction, so everybody describes the supermoon. And a supermoon is... sort of describes, it's a bit vague in its own definition, to be honest, but it describes when the moon is full near to perigee, when the moon's orbit brings it closest to the Earth. So at that position, the moon appears slightly larger and brighter than it would at other times. Well, on the 2nd of September, when the moon reaches its full phase, it'll be quite close to the opposite of perigee in the moon's orbit, a point known as apogee. Apogee actually takes place on the 6th of September. So that means that the full moon you get on the morning of the 2nd of September is one of the smallest in terms of its apparent diameter for 2020. And unofficially, that's known as a micromoon. So that's the opposite of a supermoon.
Oh, dear, oh, dear. So, yes, anyway, moving on, the 12th of June. We have a photo opportunity, don't we, Pete?
We do.
We have Ganymede's shadow in transit. So if you catch Jupiter early enough through a telescope in the evening, we'll be able to see the end half of a Ganymede shadow transit. This happens because as the Galilean moons pass in front of Jupiter, their shadows are cast onto the cloud tops. And with Ganymede, it's really quite an effect because you get a really big black shadow, and the Ganymede shadow is on the midline of the planet, so this is the central meridian, at 2100 BST, that's 2000 UT, and the transit itself comes to an end at 2255 BST.
So quite well timed, actually, to get out and have a look at that. On the morning of the 13th, we've got Venus again, which is hitting the headlines because it'll be a couple of degrees south of the Beehive cluster, M44. So that's a good photo opportunity there. And on the following morning, on the 14th, Venus and M44, the Beehive cluster, are joined by a 14% lit waning crescent moon. So that'll be a really photogenic scene to try and get a shot of. So if you are up about 4 o'clock BST, the centre of the moon sits 1.5 degrees north of M44 and 3.8 degrees north of Venus. So good meeting there.
Yeah, that'll be a nice one to choose, nice one to catch if it's clear.
Okay. Well, the moon is also quite useful over the 16th through to the 18th. So on the 16th, in the morning sky, there's a chance to spot a very thin waning crescent moon, which could be seen rising above the east-northeast horizon about 0515 BST. That's time, by the way, is correct for the centre of the UK. So if you live in other locations, there'll be a few minutes difference there. But if you do manage to spot that moon, you'll be looking at a 2% lit crescent, which is quite good.
It is quite. It's also it's not something you see very often. It's a 2% lit crescent. It's
Especially a waning.
That's right.
Crescent, because you have to get up quite early for that.
And that does actually look quite different to when the other side's lit. It is notable. The other side, the crescent of the moon, is not got as many features as you see it in the evening sky.
That's a really good point. It looks quite odd. It looks almost as if somebody's taken a scraper and scraped off all the detail of the moon, because you've got the large Oceanus Procellarum, which is the main sort of sea which runs around that bit, and it just creates quite a smooth-looking moon, really. It's quite an odd thing.
It is odd.
And not many people actually have seen that, joking apart, because you do have to get up early in the morning to see it. So you have to make an effort for that one. But if you can't be bothered getting up early in the morning, there is a thin waxing crescent moon, which may be visible potentially 20 minutes after the sun has set on the evening of the 18th of September for a very short space of time. So you've got to have a good flat western horizon, and you've got to look after the sun has gone below the horizon. Make sure the sun has properly set before you do look for it. But here, quite interestingly, the moon is at perigee. So it's close to its closest point to the Earth. So that crescent will be slightly larger and brighter than it would normally be. So actually in this position, perigee actually does work for you, because it might make that crescent a bit easier to see, but it is going to be quite a thin one you're looking for there.
I mean, what are we going to call this? A super crescent?
If you want.
Is that?
Yeah, look for the super crescent. The super crescent moon. Okay, well, also, let's finish off with the moon. On the evening of the 25th, there's a chance to see another interesting clair-obscur effect. That's a shadow and light effect on the moon called the Eyes of Clavius, which is what happens when the morning light floods into the crater. It doesn't actually illuminate the crater's floor, but just the tops of two of the large craterlets inside Clavius. So it makes it look as if you've got two eyes inside the dark oval shape of the crater. Have you ever seen that?
I haven't. I shall look out for the Eyes of Clavius, though. It sounds like a 1950s slasher sci-fi film, The Eyes of Clavius.
Yes,
I'll look out for it, Pete.
That's how I'm going to see it now. It's quite dramatic, actually. It's quite something to see, but you have to catch it at the right time, because, of course, it doesn't take long for the moon's light to flood into the crater, and then it completely wipes out the eyes. But no, well worth looking out for.
Okay, well, let's move out to the stars. The Northern Hemisphere's autumn equinox actually occurs at 14:31 BST, that's 13:31 UT, on the 22nd of September. And this represents the date when the length of the Northern Hemisphere night is growing at its fastest rate of the year. Common misnomer that people think is that equinox marks the time when all places on the Earth have equal day and equal night, and that's not really the case, is it?
No, it isn't. The precise term for such a day is called an equilux, and that occurs a few days before the spring equinox and a few days after the autumn one. And awkwardly, well, I suppose that's why people don't mention it that much, the precise date of an equilux varies with latitude. So you can't specify it as an absolute for any a general country. It actually varies slightly with your position where you live, but it's splitting hairs really, because the actual difference isn't great in the day and night time length. They are almost balanced at that time of year. But I think the big thing we have to take away from that is the fact that it creates a dramatic effect, because as the length of night is increasing in size at its fastest rate around the autumn equinox, for the Northern Hemisphere, I should say, that means that the spectacular constellations that we associate with autumn and winter get a bit of a boost. They come into view in a much more dramatic way.
Yes, and it's a reminder as well, isn't it, that the longer, colder nights are on the way.
Yes.
So this means the area of the sky which is sort of rich with the Summer Triangle and the Milky Way, continues to be visible during September. In fact, I think it's always surprises me just how long the Summer Triangle hangs around. It hangs around long after summer.
Well, you can see it in December, can't you?
You can, yes.
Or the northern part of it, yeah. But well, I suppose let's take a look at the southernmost star then, while it's still visible to us, and that's Altair, or Alpha Aquila, and that's easily identifiable because it has two fainter stars either side of it.
Yes, and they're not particularly brilliant. In fact, the constellation of Aquila represents an eagle. I've never been able to see that myself. Its stars form a sort of distorted X pattern. At the southern end, there's a small curve of stars that are formed by Lambda and 12 Aquilae, together with Eta Scuti. And not far from here is this beautiful open cluster M11, known as the Wild Duck Cluster. That's one of my favourite open clusters of the night sky. And it does actually look like a flock of wild ducks in flight.
You've got a good imagination there, then. But I
think it does.
It's supposed to be, it's the V in the cluster, isn't it? It's a line of stars which forms a V, which is supposed to look like that weird pattern you get when ducks are flying across the sky together. And it's an immensely rich open cluster. It's quite a stunning open cluster to look at through a telescope, especially a large one, I have to say. If you look at with a smaller one, you may just see it sort of as a mistiness there. But with a larger or mid-sized to a large one, it's just incredible.
It is. The amount of stars in it. It is a stunning object. The wild duck, of course, sits close. The cluster itself sits close to the top of a diamond-shaped constellation of Scutum the Shield, and the northern end of this little narrow diamond is marked by Beta Scuti, and the southern end is marked by Gamma Scuti.
Okay, well, and if you locate Gamma, there are a number of interesting objects to the west and south of that star, including M16, the Eagle Nebula, which is always a bit of a disappointment through a telescope, I find.
It is. I think it's because it's got a low brightness, isn't it? It's not got a very high brightness, and there isn't a lot of structure to it. At least a few times I've seen it, anyway.
You can see the cluster, but it's really difficult to see the nebulosity.
It is,
And of course, you've got M17, which is the opposite, because M17 is quite bright and quite impressive, and that's got loads of different names. M17. It's called the Swan Nebula, or the Lobster Nebula, the Omega Nebula. You name it. It's got loads of them. You've got the rich open cluster, which is M25, and it's quite an odd feature, actually, this. This is an object, especially when you consider that Messier was supposed to be hunting comets and recording objects which look like comets. He recorded the star cloud M24, which has also got a name. It's called Del Costiche, and that's huge and quite an impressive region to look at. But does it look like a comet?
No, but then neither does M44. So there's quite a few things in the catalogue that I don't think could ever be confused with comets. But nonetheless, it's nice to have a catalogue of these objects, I guess.
Okay. Well, the M24 star cloud is large and impressive, and it's good to scan it with binoculars or a telescope, I guess. And there's a similarly interesting region at the top of Scutum, which is quite close to the Wild Duck Cluster, which is called the Scutum Star Cloud. And that's so bright, if you've got dark skies, that it's been known to trigger astronomic panic when you think there are clouds appearing and you start to pack up because they're drifting in, but it's actually the Scutum Star Cloud.
You've been fooled by a star cloud thinking that the clouds were coming in.
It's got me a couple of times, I have to say.
You obviously observing of darker skies or skies that aren't obstructed, because it's never got me because I've never seen it.
Okay, well, there are lots of interesting things up there. The region north of Aquila is populated by small constellations, some well-defined and others which are frankly pretty obscure. But one of them is the constellation of Vulpecula, the fox.
Oh, yes.
Which is pretty obscure. And it used to be called Vulpecula et Ansa, which is the fox and the goose.
Sounds like the name of a pub.
It does sound like the name of a pub. I can always remember Patrick describing this, actually. He said, I don't know where the goose has gone. He said, maybe the fox has eaten him. But you've got Brockie's cluster in Vulpecula, which is Colander 399. And that's a lovely thing to look at. It's called the coat hanger because it looks a bit like a coat hanger. well, it looks exactly like a coat hanger, actually. But it's not a cluster at all. It's an asterism.
Right. And we also have, shouldn't forget, the beautiful planetary nebula M27, the Dumbbell Nebula, appears to the east-northeast of Colander 399, visible in binoculars, but through a telescope, even a small telescope, actually, because it seems to have quite high surface brightness. It is quite well structured, and it kind of looks like an apple core that's just been tossed aside.
Yeah, it does, completely.
So quite a nice object to look out for in this sort of remote area of the sky.
Yeah, well, M27 is a glorious thing to see. And you've also, what other constellations you've got there? You've got Sagitta, the arrow, which has a better definition than Vulpecula, really, doesn't it? And
it kind of does look like an arrow. It does look like an arrow ahead in flight to me.
Yeah, okay. You've also got Delphinus the dolphin, which is supposed to represent the head of a bottlenose dolphin. Does it?
Right. No. Well, I guess you could, if you really put your mind to it, you could see a leaping dolphin there, maybe.
Okay. And then, of course, the one which is furthest to the east of that little group of constellations is Equinox the foal, which...
Yes.
Yeah, let's just leave it there. Equinox has got nothing, has it, at all?
It's very difficult to see. It's quite a tough constellation because there's not much in this.
No, but as we're sort of heading towards that direction, we're heading into the stars of autumn. So I think we'll leave it there and leave those for another time. So thank you very much, Paul, as usual.
Thanks, Pete.